matrix multiplication using a computer language, let's go to Sage Math Cell and let's use the Python language. The key package I want to use here is called NumPy. NumPy is the numerical package, the package for doing numerical Python, especially involving arrays and matrix-like operations. So earlier we had a matrix 4, 2, 7, 3, 1, 4. And so I want to enter that as a NumPy array of size 2, 3. Now, when I read it off verbally, 4, 2, 7, 3, 1, 4, if I'm not careful about how I space out my words, it's not clear if that's a 2 by 3 matrix, or a 3 by 2 matrix, or a 1 by 6 matrix, or a 6 by 1 matrix. And likewise, when we enter a array in NumPy, we can actually change its shape by interpreting the same sequence of numbers in different ways. So here I've made a NumPy array with the input numbers 4, 2, 7, 3, 1, 4. And I ask it to print that, and of course, it's just going to give me one line of numbers. It's essentially giving me a single row of numbers. But I can rearrange the shape of that. So now I have declared the shape of A to be 2 by 3. And so in the computer memory, it's taking this sequence of 6 numbers and saying, okay, instead of thinking of it as a single list of 6 numbers, let's think of it as being a two-dimensional array, or a matrix, comprised of 2 rows. The first one is 4, 2, 7 of length 3, and the second one is 3, 1, 4, also of length 3. So it's the same numbers in the same sequence, but with a different shape. We can change the shape in other ways. So let's say shape could be, let's say, 6 by 1. And now the matrix is being represented as a 6 by 1 matrix, the same numbers. Now, if I wanted to input it to be the correct size to begin with, I would use extra braces. So going back to the beginning here, if I want really the 2 by 3 matrix 4, 2, 7, 3, 1, 4, I'm going to use a second set of square braces inside. So 4, 2, 7, 3, 1, 4, and print A. Notice that the outer set of braces defines the matrix, and the inner set defines each row, and the rows are separated by an extra comma. Okay, so now let's think about how to do matrix times vector multiplication. I'm going to do this a slow way, and I'm going to do it the faster way. So for example, if I want to understand the elements of the matrix A, we know that they are counted with 2 rows and 3 columns. So if I want to think about Aij, I can loop over all of the rows and all the columns and say print the I equals So here what we're going to do is we're going to loop over both rows of the matrix. And within each row, we're going to loop over the elements, the columns of that matrix. And we're going to look at the entries, the ij entry. So this print format command here is saying I'm going to print off this sentence here. And the way this works is that if I use these curly braces, each time I use a curly brace, it's going to substitute in the variable seen on the right. So whatever i's, it's going to plug that in here. Whatever j's, it's going to plug that in there. And it's going to take aij and plug it in there. And this is the syntax to access an individual element of the matrix. So aij refers to the ith row in the jth column of A, what I was by hand drawing as lowercase aij. Let's evaluate this to see what happens. Okay, so The I equals 0, j equals 0 entry of A is 4. The I equals 0, j equals 1 entry is 2, and 7, and 3, and 1, and 4. So notice we have the first row is 4, 2, 7. The second row is 3, 1, 4. Now the thing that's interesting about this is notice we count from 0. This is very common in computer languages. It's much more convenient to count from 0 than count from 1 in many situations. And so that's usually the convention on a computer. Of course, by hand we still write from 1 to n. Say we count 1 and 2 and 1, 2, 3, but we know from a previous video that, say, range 3 counts 0, 1, 2, and the entries of A are indexed that way also. So again, if I just say print A, I get 4, 2, 7, 3, 1, 4. So if I want to say access the 7 here, I would say print A, so row 0, the first row, and 0, 1, 2, the last entry would be 2. So print A02 is giving me that 7.